So postulate 15 is, aka corresponding angle postulate, is when you have two lines and they are parallel, cut by a transversal. That is like angle 2 and angle 6. They are right or left or here and here, all different kinds of combinations you got here. But they are corresponding angles. That means angle 2 is congruent to angle 6. Theorem 3.1, aka alternate interior angles theorem, is when you have two lines, they are parallel, has to be important here, parallel, and they are, well, as the other ones, alternate interior. So that means they are across from each other, like this, diagonally, like 5 and 4 here. And these as well are, angle 4 is congruent to angle 5. Theorem 3.2, aka alternate exterior angles theorem, is the same thing as the other one, cut by transversal here. Same thing except on the exterior, like 2 and 6 on the exterior. Now these would be equal. Make sure you draw these. You don't know that they are parallel. Draw the triangles. 2 and 6 are congruent here. So angle 2 is congruent to angle 6, as well as 3 and 5 here. Also congruent. Theorem 3.3, angles theorem. This one's a little weird. You have two parallel lines here, cut by a transversal. Now instead of them being alternates, they instead are on the same side. So like 3 and 5. And instead of them being congruent, so angle 3 plus angle 5 actually equals 180 degrees. Now let's go into proving lines are parallel. This is in 3.3. Postulate 16 is corresponding angles converse. And that means postulate 16 is the converse of postulate 15. It states if two lines are cut by a transversal, so the corresponding angle are congruent, then the line are parallel. So let's look more into that and other theorems. Like I said, postulate 16 is two lines cut by transversal, and you know that this angle and this angle, let's name this 2 and 6, these are congruent here. So by corresponding angles converse, you will know that these two lines are parallel. This is the converse of postulate 16. It's backwards of it. Theorem 3.4 is alternating interior angles converse, the same as the backwards of theorem 3.1, as we see this trend going here. Two lines cut by a transversal, and if these angles or these angles are congruent, then these would be parallel here. Theorem 3.5 is alternate exterior angles converse. It's where you have two lines here cut by a transversal, and on the exterior you have two lines that are of equal value. So if these are equal, then that means that the lines are parallel. We see this trend continuing because they're converse. You prove that the lines are parallel. Two lines cut by a transversal. This is theorem 3.6, consecutive interior angles converse. It's where two angles right here, if these two angles add up and equal 180 degrees, then these two lines are parallel. Remember that the converse of a true statement is not necessarily true. So each converse of a theorem can be proved. Now let's go into paragraph proofs. A proof can be written in paragraph form too. The statements and reasons in paragraph proof are written in sentences, using words to explain the logical flow of the argument. Now let's look at Theorem 3.7, the transitive property of parallel lines. This states, if two lines are parallel to the same line, then they are parallel to each other. So, if P and Q are parallel, and Q and R are parallel, then P and R are parallel to each other. Very simple. Let's go into slope. Slope 3.4. Slope of a non-vertical line is the ratio of a vertical change, or rise, to horizontal change, or run, between any 2 points on the line. As you see, algebraically, m will equal slope. How do we find slope now? Remember that a line has to have at least 2 points on it. So you can pick any 2 points and do the slope point formula. You might ask, what is the slope point formula? The slope point formula is y2 minus y1 over x2 minus x1. Let's do an example.
Okay, so we have our slope formula here. y2 minus y1 over x2 minus x1. Rise over run. So let's pick any 2 points. Say we have a line. I'll just use 2 points for an example. 2, 3, let's say 10, 15. So let's do our equation. This is, remember, x1, x2, y1, y2. So let's do our equation. 15 minus 3 over 10 minus 2. And that shall equal 12 over 8. Now, even though this is like this, we can simplify the fraction down to get a lower slope. It'll still equal the same thing. What you have to remember, though, is you have to remember you can never change slope into a mixed fraction. It doesn't work like that. So if we divide by 4 on each side, that will equal 2 and 3. 3 over 2. That is our slope of the line.
Okay, so negative slope falls from left to right. Positive slope rises from left to right. Zero slope is horizontal. Undefined slope is vertical. Those are very important definitions. Write and graph equations of lines. 3.5. Slope-intercept form is y equals mx plus b. M is the slope and b is the y-intercept. Standard form is ax plus by equals c. Both a and b in that equation cannot be 0. A can be 0 and b can be 0, but both of them cannot be 0 at the same time. Now you can change slope-intercept into standard form and vice versa, either way. Let's look into proving theorems about perpendicular lines.